Dimensional analysis. The definition for dimensional analysis is the process of using the ratio between two measurements to convert a measurement from one unit to another. So, in other words, using math. For example, 1 foot is equal to 12 inches. To convert 24 inches into feet, we would first write down 24 inches and then place our equivalent. 1 feet is equal to 12 inches. We would cross-cancel the inches, and our answer would be 2 feet. A conversion factor is a ratio between two different units of measurement. Usually it is represented as a fraction in dimensional analysis. For example, 60 seconds is equal to 1 minute. 12 inches is equal to 1 foot. 60 minutes is equal to 1 hour. So this is how you would set up dimensional analysis. The other way of writing dimensional analysis or referring to dimensional analysis is parentheses math. This is because the conversion factor is set up as a fraction inside parentheses. The units are treated the same as variables in math. They are very important. This means that units can be canceled out when divided by themselves, like x divided by x. This also means that whatever unit you're looking for is placed on top of the fraction, while the unit you started with will be placed at the bottom, or the denominator. When using factors in dimensional analysis and significant figures, we are going to use them as fractions, and we're going to multiply by our given amount. This cancels out the given units and converts them into what you want, or the units that you want. For example, how many feet is 24 inches? This is what the math would look like using dimensional analysis. 24 inches times the quantity of 1 foot divided by 12 inches equals 2 feet. For dimensional analysis, the final answer is also rounded to the same amount of significant figures as the starting number. That's the only number we are taking into consideration for significant figures. This is because conversion factors are considered to have infinite significant figures. Remember, whole numbers can be written in a number of different ways, so we say that they have an infinite amount of significant figures. Here's our first practice problem. If a driver travels 323 kilometers by car in one day, how many miles is this? 1.6 kilometers equals 1 mile. First, we're going to set up the problem. We always write down the given first, and then we set up the parentheses. In this case, our given was 323 kilometers. We don't know what we're putting in the parentheses yet, but because this is a dimensional analysis problem, we know we are going to need a parentheses. We are also, the next step would be to put the units in the parentheses. Remember, the units that you want go on top, the units that you have go on the bottom. In this case, we want miles, so the mi will go on top of the fraction, and we have kilometers, so we will put that on the bottom because we want it to cancel out with what we've been given. All right, now we are going to insert the numbers for the conversion factor. In our problem, we were given a conversion factor. Sometimes you have to look this up. Our problem tells us that 1.61 kilometers is equal to 1 mile. So we are simply filling in the numbers that correspond with the units that we've already placed. Next, we are going to solve the problem. 323 times 1 is 323, divided by 1.61, and we cancel out the 2 kilometers to leave the units that we want. Our answer is 200.62 miles, but we have to consider significant figures. The original number, 323 kilometers, has 3 significant figures, right? By rule number 1 of sig figs, if they are non-zeros, they are considered significant figures. So we must round our 200.62 to 201 miles. Here's our second problem. A student measures an insect to have a length of 3.55 inches. How many centimeters is this? And then it gives us the conversion factor. 2.54 centimeters is equal to 1 inch. Very well. We're going to start by writing down the value that we are given, 3.55. Do not forget the units. The units are inches. And because this is a dimensional analysis problem, we know we are going to need a parentheses. So we're going to set up the parentheses. In our next step, we are going to fill in the units for the top and the bottom of the parentheses. We were given inches, so inches go on the bottom in the denominator spot. We want to find centimeters, so centimeters or cm goes on the top of the fraction. Very well. In the next step, we look at our conversion factor, and we fill in the parentheses. We know that 2.54 centimeters equals 1 inch, and we are going to place the centimeter value on top and the inch value on the bottom. The last step is to solve this. So we have 3.55 times 2.54. Remember, the numerator is going to multiply with the numerator and then be divided by the denominator. So once they are multiplied together, we divide the product by 1 and we get the product itself. Also, do not forget to cancel out the units, right? So we want to get rid of the inches and we want to have centimeters left. So our calculator answer in this case is 9.017 centimeters. But we have to consider significant figures. Our given value was 3.55 inches. This has 3 significant figures in it, so our answer must have 3 significant figures. Therefore, we are going to round our calculator answer of 9.017 centimeters to 9.02 centimeters. All right, what happens if there's more than one unit? If there's more than one unit, you need one pair of parentheses for each of the units to be converted. For 2 units, this means you want 2 sets of parentheses. If the given unit has 2 different ones, for example, miles per hour, the unit that is second is placed on top of the second set of parentheses. This is because the units must be on opposite sides of fraction bars in order to cancel out. Similarly, if 2 units have no direct connection, for example, seconds and hours, they also need 2 parentheses to go through a middle unit linking the 2. Very well, our practice problem number 3. A bicycle travels at a speed of 19 kilometers an hour. How many miles per minute is this? And then it gives us our 2 conversion factors that we need. 1.61 kilometers is equal to 1 mile, and 60 minutes is equal to 1 hour. Whenever units are written with a slash, it means the second one is the denominator. So what we're really saying is 19 kilometers per hour. Very well, we're going to start by setting up this problem. Now, we know we are going to have to convert 2 units, so we've set up this problem with 2 sets of parentheses. And we've also placed our given measurement, in this case 19 kilometers an hour. Very well, the next step is going to be filling in the units themselves. Remember, we are placing what we want on top and what we're given on the bottom. We also have to make sure to cancel them out, so they have to be placed in the correct position. If we start off with kilometers per hour, we want to get rid of kilometers. So kilometers in the first set of parentheses will go in the bottom. We want to end up with miles, so miles will go on top. Now, in our original measurement, hours was on the bottom. So in the second set of parentheses, we will place the hours on top because they have to cancel with the denominator hours in the given measurement, 19 kilometers an hour. And we want minutes, so we will place minutes on the bottom of the second parentheses. Very well, in our next step, we are going to fill in the numbers for each conversion factor into each parentheses. Remember, you are given the conversion factors, so you just have to place them along with their corresponding unit. So we have 19 kilometers per hour times 1 mile over 1.61 kilometers times 1 hour over 60 minutes. Next, we're going to solve. We have 19 kilometers times 1 mile. The kilometers and the kilometers from the first set of parentheses are going to cancel out. And 19 kilometers times 1 mile is 19. And then 19 kilometers times 1 mile times 1 hour will cancel out to just 19, right? 19 times 1 is just itself. So 19. The hours are also going to cancel out with the hours from the given measurement, right? So now we've got no kilometers, no hours. So we are left with the units that we want, miles per minute. And we've got 19 on top, and we're going to divide the 19 by 1.61, and then divide whatever we get from that by 60 minutes. Our answer in the calculator is 0.196 miles per minute. Now, however, if we go back to the original equation, the given measurement has 2 significant figures. So we have to round that 0.196 to 2 significant figures. So our final answer is 0.20 miles per minute. Remember that by rule number 4, a trailing 0 is considered a significant figure if there is a decimal point. And by rule number 3, a leading 0 is never a significant figure. So this final answer has 2 significant figures. Practice problem number 4. Students are given 3.5 hours to complete a test. How many seconds is this? We're given the conversion factors. 60 minutes is equal to 1 hour, and 60 seconds is equal to 1 minute. Since there's no direct conversion from hours to seconds, you need 2 conversion factors. You need 2 sets of parentheses for each conversion factor. 1 for hour to minute, and 1 for minute to second. Very well, our first step is to set up the problem. 3.5 hours was our given measurement, and we need 2 sets of parentheses, right, for that middle step in converting from hours to minutes. Our next step will be to fill in the units. We know that we are given hours, and we need that middle step to convert between minutes and hours. We place the hours on the bottom for the first set of parentheses so they cancel out with our given hours. Next, in the next parentheses set, you are going to place minutes on the bottom, so it cancels out with that first set of parentheses. So the only thing you have left is what you want, which is seconds. In our next step, we are going to look back at the conversion factors and we're going to fill in the numbers